I'm Richard Hogan. I'm a Chief Global Architect at IBM, working specifically in the Microsoft practice. That means Azure, M365, Copilot, security, and increasingly the development, tooling, and platforms that sit underneath all of it. So GitHub is not peripheral to that work. It is central to it. Repositories, pipelines, security scanning, Copilot integration. It is in almost every conversation I have with clients. And yet, I have never formally certified in it. I've used it for years. I know my way around it, but there is a difference between knowing how to use a platform and being able to explain it precisely. And certification has a way of making that gap very visible very quickly. So I've decided to fix that. All 5 GitHub certifications in sequence over the next 12 to 14 weeks. Starting with Foundations, then Actions, then Gas, Copilot, and Administration. Every session producing a recording and a companion blog post. I don't plan to do this on a test environment or a tutorial project. I'm planning to do this against real work. The hands-on sessions use actual repos, actual pipelines, actual security configurations. That is partly because I learn by doing rather than reading, and partly because I think it produces more useful content than yet another walkthrough of the documentation. If you're studying for any of the GitHub certifications, these recordings follow the official exam domains in order and cover what actually gets tested. If you're just interested in how GitHub works in an enterprise context, that's fine too. Most of what I cover is relevant regardless of whether you ever sit one. So, Session 1, GitHub Foundations, Domain 1. Domain 1 is called Understand Git and GitHub Basics. Carries 25 to 30% of the exam weight, making it the heaviest single domain. It is split into 2 parts, and I'm going to cover it across 2 sessions. This session is the first half, Version Control Fundamentals. What version control actually is, the difference between Git and GitHub, and the 3 core Git concepts you need to know cold, which are repositories, commits, and branches. The next session covers the second half, working with GitHub as a platform. If you use GitHub regularly, you will probably recognize everything here. But what gets tested is precision rather than familiarity, and those are 2 different things. So that is how we will treat it. Let's start with the problem. Before version control existed, collaborative work on files meant emailing attachments around. You would name things like final, then final v2, then final revised. There was no reliable way to know what changed between versions, who changed it, or how to go back to an earlier state if something went wrong. If 2 people edited the same file at the same time, someone's work got overwritten. Every team that has ever shared a folder on a network drive knows this pain. Version control is a system that solves that problem. It records changes to files over time so that you can retrieve any specific version later. That is the formal definition and is the one to know. Every change is tracked. Every change is attributable to a person, and every previous state is recoverable. There are different version control systems. The one that matters here, and the one that most of the world uses today, is Git. Git is what's known as a distributed version control system. The word distributed is important, and it comes up in questions. In older centralized systems like Subversion or CVS, there was one central server that held the full history. Everyone connected to that server to get files and submit changes. If the server went down, nobody could do anything. If you were offline, you could not commit, you could not branch, and you could not look at the history. Git works differently. With Git, every person who works on a project has a complete copy of the full history on their own machine. Not just the current files, but every change that has ever been made. You can commit, create branches, review history, and merge entirely offline. The connection to a central location only happens when you choose to share your changes. That is what distributed means in this context. Now, the first core concept, the repository, often shortened to repo. A repository is the fundamental unit of work in Git. It is a project folder, but it is more than just the files you can see. Inside every Git repository, there is a hidden folder called .git. That hidden folder contains the entire history of the project. Every branch, every commit, every piece of metadata Git needs to track changes. The files you can see are the current state. The .git folder is everything that has ever happened. Let me show you how to create one. On the command line, I navigate to an empty folder and type git init. That's it. Git has initialized this folder as a repository by creating the .git directory inside it. There is nothing in the history yet because we have not made any changes, but the repository exists. The other way to create a repository is on GitHub itself, via the web interface. So you click on New Repository, give it a name, choose whether it is public or private, and GitHub creates it for you. We'll come back to GitHub later, but for now, the important thing is that either way, locally or on GitHub, what you end up with is a repository, a folder with a .git history inside it. I'm going to add a file to this repository, a simple readme.md, which is a text file written in a format called Markdown that we will cover in the next session. The file exists in the folder now, but Git is not tracking it yet. Git does not automatically track every file. You have to tell it what to include. I do that with git add. I type git add readme.md, and now Git knows about this file and is ready to record its current state. This staging step, putting files into what Git calls the staging area, is how you control exactly what goes into each snapshot. Which brings me to the next concept, the commit. A commit is a saved snapshot of the project at a specific point in time. When I type git commit and add a message describing what I've done, Git takes everything in the staging area and saves it as a new commit. That commit contains several things: a snapshot of every tracked file at that moment, the message I wrote, my name and email address as the author, a timestamp, and a reference back to the previous commit called the parent. That reference to the parent is important because it is how Git builds a chain. Each commit points back to the one before it. That chain is the history. When you look at a Git log, you are looking at that chain. So let me make a couple more changes so you can see this. I will edit the README, stage it, and commit it. And again, now when I run Git log, I can see 3 commits, each with a message, a timestamp, an author, and a unique identifier called a hash. I can return to any of these states. That is version control working, a structured, queryable, recoverable history of everything that has ever happened in this project. Now the third core concept, branches. A branch is a pointer to a commit, and I want to be exact about this because it is the most commonly misunderstood concept in Git. A branch is not a copy of the codebase. It is a separate folder. It is a lightweight reference, a label that points to a specific commit. Right now, this repository has one branch called main. Main is pointing at the most recent commit. When I create a new branch, I type git switch -c feature -branch. And what happens is Git creates a new pointer called feature -branch that starts at exactly the same commit main is pointing at. Both branches are looking at the same place. Now, I make a change on the feature -branch. I edit a file, stage it, and commit. Feature -branch moves forward to the next commit, but main stays exactly where it was. The 2 branches are now pointing at different commits, which means they represent different states of the project. You can see this in GitLog with the graph option. Main is here and feature branch is here, They have diverged. To bring them back together, I merge. I switch back to the main with git switch main, and then I type git merge feature-branch, and Git takes the changes from feature-branch and integrates them into main. Main now moves forward to include those changes. If there are no conflicts, meaning Git can figure out how to combine the changes automatically, this happens cleanly. If both branches change the same lines of the same file, Git will ask you to resolve the conflict manually. This is the core of Git. Repositories hold the project and its history, and commits are the snapshot in that history, and branches are pointers that let you work on different things in parallel and merge them together when you are ready. There's one more thing in this half of Domain 1, and it is the distinction that matters most, the difference between Git and GitHub. Git is the version control system. It runs locally. Everything I have just shown you works on your machine with no internet connection. GitHub is a platform built on top of Git. It hosts repositories remotely and adds a set of collaboration, automation, and management features that do not exist in Git itself. Here is the practical test. If you can do it in a terminal with no internet connection, it is Git. If it requires a browser or GitHub's API, it is GitHub. When I take my local repository and connect it into GitHub, I'm adding what Git calls a remote, a copy of the repository stored on GitHub servers. I push my local commits up to that remote, and now the repository exists in both places. Other people can clone it, which means they download their own complete copy of the repository and its full history, and they are working with the same project. That shared remote repository is where GitHub's features live. Pull requests, issues, actions, security scanning, project management. None of these exist in Git. They are all GitHub. And we will go through them properly in the next session. It's important to note you can use Git without GitHub. You could use GitLab, Bitbucket, or just a local repo on your machine with no remote at all. However, you cannot use GitHub's features without Git underneath them. That is the boundary. Now, before I wrap up, two things that catch people out in this half of Domain 1. The first is exactly that distinction, treating Git and GitHub as interchangeable. It seems pedantic until you are in an exam question that turns it on it. Push to GitHub is not the same as push to a remote. GitHub is one remote host. The remote could be anywhere. The second is branches. Most people understand them practically. You branch, you work, you merge. But you need to be exact about what a branch actually is. A copy of the code base is wrong. A branch is a pointer to a commit. That is why creating a branch takes milliseconds, regardless of how large the repo actually is. They are cheap and disposable by design. So, a few things to take away from this session. Version control records changes over time and lets you retrieve any previous state. Git is a distributed version control system, which means every contributor has the full history locally. A repository is a different folder with a .git directory that holds the complete history. A commit is a snapshot with a message, author, timestamp, and parent reference. And a branch is a pointer to commit. And finally, Git is the local version control system, while GitHub is a platform built on top of it that hosts repositories and adds collaboration features. That is the first half of Domain 1. Next session, we will stay in Domain 1 and move to the GitHub side of that line. Account types, the GitHub flow workflow, Markdown, and when to use GitHub Desktop and GitHub Mobile. Thank you for watching, and we'll see you in that session.